Let's be honest, who hasn't wished for a superpower? You know, the ability to see things that are completely hidden, to sense objects from miles away, even if it's pitch black or totally foggy. Well, what if I told you that superpower actually exists, and it has totally, completely reshaped our world? Today, we're going to pull back the curtain on the incredible technology of radar.
Just take a second and really think about that. How would you even do it? How would you guide a jumbo jet through a thick bank of clouds, or navigate a huge ship through dense fog with, perfect clarity? It seems impossible, right? Well, solving that exact problem led to one of the most important inventions of the 20th century.
And the solution has a name. Radar. It's actually an acronym that stands for radio detection and ranging. And what it does is pretty amazing. It uses invisible radio waves to basically paint a picture of the world around us. It gives us a sense that goes way, way beyond our normal human abilities.
Now you might be thinking this sounds incredibly complicated, but at its very core, the idea is so simple. It's something we can all get right away. If you've ever shouted into a canyon and waited to hear your voice bounce back, well, you already understand the basic principle of how radar works. It really is all about the echo.
Okay, so let's start with the most fundamental thing radar does, figuring out how far away something is. It all just boils down to sending out a signal and then timing how long it takes for that signal's echo to come back home.
So here's how it works, and it all happens in literally the blink of an eye. First, a transmitter sends out a quick pulse of radio energy. Then, that pulse travels through the air until, bam, it hits something, let's say an airplane. Third, a little bit of that energy bounces off the plane and starts heading back, just like an echo. And finally, a receiver, which is often part of the same antenna, snags that faint returning signal.
And here's where the magic happens. We know exactly how fast radio waves travel. They move at the speed of light. So the system does a little bit of quick math. By measuring the tiny delay between sending the pulse out and getting the echo back, it can calculate the precise distance to that airplane. It's incredibly accurate.
But, just knowing the distance is only the beginning. That little returning echo is packed with so much more information. It's almost like it's speaking a secret language, and if we can decode it, we can learn all sorts of things about an object, like its speed, its size, and even its shape.
For speed, radar uses a principle that you've definitely experienced before. It's called the Doppler effect. Think about an ambulance siren. You know how the pitch gets higher as it comes towards you and then lower as it drives away? Radar does the exact same thing, but with radio waves. If a plane is flying toward the radar, the echo's frequency gets squeezed and comes back higher. If it's flying away, the frequency gets stretched out and comes back lower. And that little shift tells us its speed, instantly.
So this all leads to a really interesting question. If radar can see things, why are some objects so much harder to spot than others? Is it just about being big or small, or is there something else going on?
Well, the answer comes down to this concept called radar cross-section, or RCS for short. You can just think of it as a measure of how bright or loud an object appears on a radar screen. And here's the key thing. It is not just about size. The object's shape and the material it's made of are hugely important. You could have a giant object with a special shape that has a smaller RCS than a small, really reflective object.
And that concept, the idea of playing with an object's radar cross-section, that is the entire secret behind modern stealth technology. The whole point isn't to be truly invisible. The goal is to make your echo so tiny that you just get lost in all the other background noise.
Stealth aircraft do this in a few really clever ways. First, they use all these sharp, flat, angled surfaces that are designed to bounce radar waves away from the receiver, not back to it. They're also coated in these special radar-absorbing materials that act like a sponge for radio energy. And finally, everything, weapons, engines, you name it, is tucked away inside the plane to keep its shape as smooth and non-reflective as possible.
So, we get the how, but so what? Why does any of this matter to us? Well, this technology isn't just for super-secret military jets. It's actually a hidden but totally essential part of our day-to-day lives.
I mean, just think about it for a second. Radar is what lets air traffic controllers guide hundreds of planes through the sky safely. It's how meteorologists can see a storm coming from 100 miles away. It's the reason you get a speeding ticket. It guides ships at sea, it helps self-driving cars see the world, and it even lets us map the surfaces of other planets. It is absolutely everywhere.
And as powerful as radar already is, believe it or not, we're just getting started. The future of this technology is heading towards systems that are way smarter, more connected, and more powerful than anything we've seen before.
I mean, we're talking about some seriously futuristic stuff. People are developing cognitive radars that can actually learn from their surroundings and adapt on the fly. They're using AI to fish out impossibly faint signals from a sea of static. They're building networks of radars that all work together to build a much richer, fuller picture of what's out there. And scientists are even looking at quantum physics for the next giant leap in detection.
Which really brings us to one final thought. We've built this amazing technology that lets us see the invisible with stunning precision, and it's only getting stronger. But as these systems get smarter and more woven into the fabric of our lives, it really makes you wonder, where do we draw the line between detection for safety and just constant, everyday surveillance?